Okay, when we looked at fundamental counting principle to rearrange the letters in Leduc, remember we just do 5 choices for the first letter, then 4, then 3, then 2, then 1. So that gave us the answer of 120. And then yesterday we looked at if you do factorial, it's easier just to write that as 5 factorial, so that's also 120. Okay, so what we're going to look at today now is permutations. So what that means is how many different ways could you arrange those 5 letters, choosing a certain number of them. So if we were going to pick all 5 letters, what we do is we use 5 permutation 5. So it says out of 5 letters, we're going to rearrange 5 letters. So on your calculator, if you did 5p5, that would also give you 120. So to find your calculator button for this one, it's just like factorial. Go to math, then you got to go to probability, and then number 2 is NPR. So on your calculator, what you would do for this one is you'd type in 5, then go to the NPR button, and then type in 5 again, hit equals, and it would give you the 120. So it's the same thing as factorial. It's just sort of what this button comes in handy for is you can do smaller groups. So if we go back to the Leduc question, so let's suppose we have Leduc, and in this case I say instead of picking all 5 letters, I just want you to arrange how many 3-letter words could you get. So if we were using fundamental counting, we would say we got 5 choices for the first letter, 4 for the next, and then 3 for the last, so that would give us 60 for an answer. So that's fine. If we were to use the factorial method, what would happen is we can't just use 5 factorial anymore because that would give us 5, 4, 3, 2, 1. So what we have to do is we have to divide by the 2 letters we don't want, because those last 2 letters, if you flip them the other way around, they're going to get cancelled anyway. We're only using 3 letters, so those last 2, if they were flipped, would give us the exact same word. So in this case, we'd have to divide by the 2. So if you're using factorial, you got to remember to divide by the letters that you don't use. And then if we use the new notation, the permutation notation, what NPR actually is in terms of a formula, it's the n factorial divided by n minus r factorial. So in this case, if we're doing 5p3, actually what the calculator is doing is it's doing 5 factorial divided by 5 minus 3 factorial, which is the 2 that we're getting here. So you can see that the p notation is the exact same thing as doing factorial. It's just maybe a little bit easier way of doing it. So if I said I want to pick 5 letters out of the 3, just type in 5p3 on your calculator, and that'll give you the 60. So the permutation notation is handy for when you do groups. So instead of having to do fundamental counting all the time, it works really good if you've got a smaller group of numbers. So if I said, let's do a question where you have a word with, let's suppose we have 8 letters. So we have the word, let's use the word sandwich. Okay, so we have 8 different letters there. So if we were to rearrange all 8 letters, the easiest way to do it would be doing 8 factorial. But let's suppose I only want to do 4 letters of the 8. Okay, factorial, you'd have to go 8 factorial divided by 4. Actually, 4 is a bad one. Let's change it to just 2. Let's suppose we only want 2 letters out of the 8. So if we were to use fundamental counting, we'd have 8 times 7, right, because we only want 2 letters. So that'd give us 56. If you want to use factorial notation, you'd have to do 8 factorial, but then you have to get rid of all the ones you aren't using, so the 6 factorial. So that would give you 56. Or the easier one is just use, we have 8 letters, and we want to pick 2 of them, and that would give us the 56. So we have basically 3 different methods to do all these questions. In some cases, the fundamental counting is going to be easier. Other cases, factorial might be easier, and then in other cases, you might want to use the NPR notation. So it just sort of depends. Typically, the fundamental counting is always good unless there's lots of them. You don't want to be writing out a whole bunch of them. The factorial works good when it's things like this, where we have just the number of letters and so on. So let's do a couple where they're a little bit more difficult. So if I said we have the word golden, oops. So if we have the word golden and we want 2 letters. Okay, so in this case we got 6 letters, they're all different, we want 2 of them. So in this case it'd be better to probably go 6P2. Okay, if I gave you the word, let's do a repetition like Kalmar. Okay, so in this case, let's suppose we're going to use all letters, so all 6 letters. So in this case, because we're not doing anything that's weird, let's do all 6 letters, that'd be 6 factorial, but in this case, because we have those 2 A's that are repeating, if the same letters, we have to divide by those repetitions. So in this case, probably factorial is the better way to go. The P notation probably wouldn't work so good. Okay, so it just sort of depends on the question what you want to do. Let's do another one. Let's suppose you had the word Soyuz. Okay, so that's a place in BC. So in this case, we got 7 letters, and we got 4 O's. So we'd have to divide by the 4 O's, but we also have 2 S's, so then we'd have to divide by that as well. So those kind of ones with repetition of letters, you're probably better to do factorial. Another one that you do often is pathways, where it says you have a grid. So let's suppose we have a grid like this, and we have to go from corner to corner. So in this case, it's the same as a letter question. We're going to go over 4 ways. So we're going to go over 4 on the top, and we're going to go down 3 blocks on down the side. And we can do any kinds of repetitions, right? We could go down this way, and then over, then down, over, like that. Or we could take a different pathway and do it something like that, and so on. So there's going to be a whole bunch of different pathways, but we're basically going over to the 4 and down 3. So no matter which pathway we take, we're going 7 different blocks, and we're repeating 4 to the right and 3 down. So that would be a way to do it with factorial. So factorial works really good for arrangements where there's repetitions, kind of like these 2 examples, where the P notation works really good when you're doing groups. So if I said we have 6 people in the class, and I want to do a group of any 3. So we're going to pick 3 people to be in some sort of group. So in that case, 6P3 would be the better way to do it. Factorial would get a little bit confusing, and so on. So 3 different ways of doing it. Tomorrow we're going to do more with permutations, where we're going to look at all kinds of restrictions and so on, and we're going to be deciding which method would work. So just to kind of get it clear, we've got these 3 different sort of formulas that we're using so far. And that's it.